Okay, so imagine you're scaling out your Nutanix cluster, right? To handle like a demanding new application, you need speed, reliability, but you also don't want to create like a total mess of network cables and configurations, which is where like this deep dive comes in. We're going to be tackling the Nutanix physical networking best practices, straight from the source, version 2.9 of their guide. And by the end, you'll know what Nutanix really needs from your network to hit that legendary performance they're known for.
It's really like having that blueprint for how to build like the perfect highway system for your data, making sure there are no bottlenecks, no traffic jams, no wrong turns.
Exactly. And the first thing Nutanix is really particular about is choosing the right switches. These aren't just like your average office switches. We're talking data center grade, high speed, low latency, and with big buffers to handle those heavy data flows without dropping a single bit. It's like comparing a minivan to a high-performance race car. They both get you from point A to point B, but the race car is designed for speed and handling.
Yeah, and Nutanix actually gives you like specific examples of switch models that work well and ones to avoid. It's like getting like a recommended shopping list from a master chef. They even call out specific Arista, Aruba, and Cisco Nexus lines that meet their criteria.
So they're not just saying, get a fast switch. They're telling you which ones will actually get you the best results. But why are those big buffers so important, especially as our Nutanix cluster grows?
Think of those buffers like shock absorbers on a race car. They help to smooth out the bumps in the road, caused by sudden bursts of traffic, preventing data packets from being dropped. If your buffers are too small, it's like hitting a pothole at high speed. Things are going to get messy. For smaller, less demanding setups, you might have a little more flexibility. But if you're dealing with larger clusters or applications that are constantly moving like large amounts of data, those buffers become critical.
Okay, so we've got our high-performance switches in place. Now, how do we arrange them to create the most efficient network for our Nutanix cluster?
Well, Nutanix has some very specific golden rules for network design. And the first one is what they call the 3-hop rule. They recommend a maximum of 3 switches between any 2 nodes in your cluster. It's all about keeping those data paths like as short and direct as possible.
Why is that 3-hop limit so important?
Imagine playing a game of telephone, right? The more people involved, the more garbled the message becomes. The same thing happens with data as it traverses multiple switches. Each hop introduces a little bit of latency and a chance for errors. By keeping it to 3 hops or less, you minimize the risk of data getting lost or delayed, ensuring smooth and efficient communication between your Nutanix nodes.
That makes sense. It's like making sure all the critical components of your Nutanix environment are within easy reach so they can communicate quickly and reliably.
Exactly. And that leads us to the second golden rule, keeping all of your Nutanix nodes within the same switch fabric.
Okay, switch fabric. Can you explain what that means?
Think of it like a well-organized sports team. Everyone needs to be playing on the same field, following the same rules, communicating effectively. In networking terms, a switch fabric is a group of interconnected switches that operate as a single entity. Keeping all your Nutanix nodes within the same fabric ensures consistent communication and simplifies management.
So it's like making sure all your Nutanix players are on the same team and working together seamlessly.
Precisely. And this is where things get interesting. Nutanix is adamant that you should never try to stretch a cluster across a WAN link.
Why is that such a big no-no?
Remember how Nutanix relies on those short, low-latency paths for its data replication and other core functions? WAN links introduce significant distance and unpredictability, which can disrupt these critical processes. It's like trying to play a fast-paced game of volleyball with half the team in a different city. The delays and miscommunications would make it impossible to win.
Okay, so we've covered the importance of choosing the right switches and following those golden rules of network design. What's next on our Nutanix networking checklist?
Now we need to get into like the specifics of how we configure those switches and carve up our network to best support our Nutanix environment. And that starts with understanding VLANs, those virtual lanes on our data highway.
Right, VLANs. I remember those from my Networking 101 class, but refresh my memory. How do they come into play in a Nutanix world?
Well, Nutanix, being a bit particular, has some strong preferences for how VLANs are set up. First and foremost, they recommend a dedicated VLAN for those VIPs of the network, the controller VMs, or CVMs. Remember, these are like the brains of the operation, managing the entire Nutanix cluster.
So it's like giving them their own executive lounge to ensure they're not bothered by the hustle and bustle of regular VM traffic.
Exactly. Isolating CVM traffic on a dedicated VLAN ensures they have a clear, high-priority path for communication. preventing delays or interruptions. That could impact the entire cluster's performance.
Makes sense. What else is there to know about VLANs in a Nutanix environment?
Well, Nutanix generally prefers to keep things simple when it comes to VLAN configuration, especially for those critical CVMs and hosts. They recommend sticking with a native untagged VLAN for these components.
Why is that? What's the advantage of untagged VLANs in this case?
Think of it like this. Tagging VLANs is like adding extra labels and instructions to each data packet, requiring more processing and potential points of failure. By sticking with untagged VLANs for the CVMs and hosts, you're streamlining the data flow, reducing complexity, and minimizing the risk of configuration errors.
So it's like choosing the express lane at the supermarket, fewer steps, less hassle, and you get where you need to go faster.
Exactly. Now,
Sure.
there's another potential source of network congestion that we need to address: broadcast and multicast traffic. Think of it like having a party where everyone's trying to talk at the same time. It quickly becomes overwhelming and difficult to understand anything.
So how do we prevent our Nutanix network from turning into a chaotic party?
Well, Nutanix has a few strategies for managing this chatter. The first is to implement what they call flood optimization techniques, which essentially set limits on how much broadcast and multicast traffic is allowed to flow through the network. It's like having a bouncer at the door, controlling the flow of guests to prevent overcrowding.
Okay, so we've laid the groundwork with those robust switches and like a well-designed network layout, but I know security is always top of mind, especially when we're talking about something as critical as like our Nutanix infrastructure. What kind of security measures does Nutanix recommend to keep our data safe and sound?
Well, Nutanix takes security very seriously, and their best practices guide highlights a few key areas to focus on. One of the first lines of defense is implementing a stateful firewall to protect your Nutanix management network.
Makes sense. But what makes a stateful firewall different from a regular firewall? Why is it so important in this context?
Imagine a regular firewall as like a simple gatekeeper. Who checks IDs at the entrance? A stateful firewall is more like a vigilant security guard who not only checks IDs, but also keeps track of who's coming and going, allowing only authorized personnel access to sensitive areas. This helps to prevent unauthorized access and keeps those bad actors at bay.
So it's not just about blocking specific ports or addresses. It's about understanding the context of the traffic and ensuring that only legitimate connections are allowed through.
Exactly. And to make things even easier, Nutanix actually provides a very detailed ports and protocols guide that outlines exactly which ports need to be open for Nutanix to function properly. It's like having a blueprint for your security team, ensuring that they're logging down the right doors and keeping the bad guys out.
That's incredibly helpful. Are there any other security gotchas we need to be aware of when setting up our Nutanix network?
There is one specific recommendation that might seem a bit counterintuitive at first. Nutanix strongly advises against enabling proxy ARP within the Nutanix VLAN.
Proxy ARP. That's one of those networking terms that always makes my head spin a little. Can you remind me what it does and why Nutanix is so against it?
Imagine proxy ARP as like a well-meaning but sometimes meddling neighbor who tries to answer questions on your behalf, even when they shouldn't. While it can be helpful in certain network scenarios, proxy ARP can actually interfere with some of Nutanix's internal processes.
Interesting. So how does proxy ARP clash with how Nutanix works?
Nutanix relies on accurately detecting whether a connection or endpoint is active. Proxy ARP can muddy the waters by responding to ARP requests on behalf of other devices, leading to confusion and potential failures. This can be especially problematic during network segmentation or when making updates to the virtual switch.
So it's like having two people speaking for you at the same time. It just creates confusion and miscommunication. Best to avoid that altogether in our Nutanix environment, it seems.
Yes, exactly. Disabling proxy ARP within the Nutanix VLAN eliminates those potential headaches and ensures smooth operation. Now, let's shift gears a bit and talk about another important consideration: stretched layer 2 networking. This could be a bit of a thorny topic, especially as we move toward more modern data center designs.
I've heard stretched layer 2 mentioned before, but I'm a bit fuzzy on the details. Can you break it down for me?
So traditionally, data centers have often used a single large layer 2 broadcast domain, stretching it across multiple racks or even buildings. It's like having one giant party where everyone can hear everyone else, no matter where they are. But with modern Leaf-Spine architectures, the trend is to terminate that layer 2 boundary at the top of the rack, creating smaller, more isolated domains.
So it's like breaking that giant party into smaller, more manageable gatherings.
Exactly. And this creates an interesting challenge for Nutanix. Remember one of those golden rules we discussed earlier? All nodes in a Nutanix cluster need to be on the same layer 2 broadcast domain.
Right, so how do we reconcile this need for a single layer 2 domain with the modern trend towards smaller, more contained domains?
Well, Nutanix provides some guidance on how to navigate this. They acknowledge that stretching a layer 2 network between two racks within the same data center is acceptable as long as those racks are part of the same switch fabric or aggregation layer.
So it's okay to have a slightly larger party as long as everyone is still in the same building and can easily communicate with each other.
Precisely. But Nutanix draws a hard line when it comes to stretching layer 2 across data centers or availability zones connected by stretched layer 2 networks.
So no trying to throw a party across multiple cities and expect it to run smoothly. Why is Nutanix so against this kind of large-scale layer 2 stretching?
Remember how Nutanix relies on those short, low-latency data paths for optimal performance? Stretching layer 2 over long distances can introduce latency and complexities, particularly with spanning tree protocols, which are designed to prevent loops in the network.
Spanning tree. That's another one of those networking concepts that can get a bit complicated. What kind of problems can it cause in a stretched layer 2 environment?
Spanning tree essentially creates like a single path for data to travel between devices, which can lead to bottlenecks and inefficient traffic flow, especially when dealing with the high bandwidth demands of a Nutanix cluster. It's like having a single lane highway connecting two cities. It just won't handle the volume of traffic efficiently.
Okay, so I'm starting to see why Nutanix is so cautious about stretched layer 2, especially across data centers. But what if we need to extend our network beyond a single data center? Is there a way to achieve that kind of flexibility without violating Nutanix's golden rules?
That's where Nutanix's Flow virtual networking comes in. It's a powerful tool that allows you to extend layer 2 networks for your user VMs across layer 3 boundaries, essentially creating those virtual tunnels you mentioned earlier.
Right. We talked about how VPCs, those virtual private clouds, can make it seem like VMs are on the same physical network, even when they're separated by routers. How does Flow virtual networking play into this?
Flow virtual networking leverages VPCs to create a virtualized layer 2 overlay network that can span multiple physical locations. It's like building a network of bridges over those layer 3 boundaries, allowing your user VMs to communicate seamlessly, as if they were all in the same room.
So it's like having a virtual party, where everyone can see and hear each other, no matter where they're physically located. But I remember you mentioning that there's a catch. This virtual party doesn't extend to the Nutanix CVMs themselves.
That's right. VPCs are specifically designed for user VM traffic. The Nutanix control plane, which relies on those CVMs, still needs to reside within a single contiguous layer 2 domain. It's like having a dedicated control room for the party, where all the critical equipment and organizers are located in one central location.
Okay, that makes sense. We're providing flexibility for our user VMs while still ensuring that the core Nutanix control plane has that tight-knit, low-latency communication it needs. Now, let's circle back to something we discussed earlier, oversubscription. We talked about the importance of right-sizing those uplinks between switches to avoid bottlenecks. But what about the connections from the Nutanix hosts themselves? Are there any specific best practices for those?
Absolutely. Nutanix recommends connecting each host to redundant top-of-rack switches. Using an active configuration, this ensures that each server has two connections to the network, both actively carrying traffic. It's like having two lanes of traffic instead of one, doubling your capacity and providing a backup route if one connection goes down.
So it's like having a backup generator for your network connection. If one goes down, the other seamlessly takes over, ensuring uninterrupted connectivity. But I'm curious, with all this traffic flowing through our network, do we need to worry about prioritizing certain types of traffic over others? In other words, is QoS, or quality of service, something we need to configure in a Nutanix environment?
That's a great question. QoS is all about ensuring that critical traffic, like voice and video calls, gets preferential treatment over less time-sensitive traffic, like file downloads. It's like having a dedicated lane on the highway for emergency vehicles. They get priority over regular traffic to ensure they reach their destination quickly.
Right. So does Nutanix have specific recommendations for QoS settings to optimize performance?
This is where Nutanix takes a bit of a different approach. They actually recommend against configuring QoS for storage traffic.
Really? That seems counterintuitive. Why would they discourage QoS for something as critical as storage traffic?
Their reasoning is that if you follow their best practices and design your network properly,
with like a non-blocking low latency fabric and minimal oversubscription, QoS shouldn't be necessary for storage traffic. It's like having a perfectly smooth highway with plenty of lanes. There's no need for traffic lights or priority lanes because everything flows smoothly.
So the best QoS is a well-designed network in the first place.
Exactly. They believe that by focusing on eliminating bottlenecks and ensuring ample bandwidth, you can avoid the complexities and potential pitfalls of QoS configuration. However, they do recommend using traffic policing on the physical switch ports to prevent things like excessive broadcast or multicast flooding. It's like having a speed limit on the highway. To prevent reckless driving and accidents.
Right, we need to keep those gossipy neighbors in check. But what about spanning tree? That's another one of those networking protocols that I know can cause issues if not configured correctly. Does Nutanix have any specific recommendations for spanning tree in a Nutanix environment? They do. Spanning tree is designed to prevent loops in the network, which can be catastrophic. But it can also cause delays in traffic flow, especially if it's not configured properly.
So how do we make sure spanning tree doesn't interfere with our Nutanix performance?
Nutanix recommends configuring the ports connecting your Nutanix hosts as either port fast or edge ports. This tells the switches to skip the normal spanning tree phases, which involve like listening and learning, and start forwarding traffic immediately. It's like giving those ports a VIP pass to bypass the security checkpoint and get right into the action.
So we're streamlining the process and eliminating unnecessary delays. That makes a lot of sense. Now, I know we've covered a lot in this part of the deep dive, but before we move on, I want to make sure we've touched on all the key security considerations. Are there any other security best practices that Nutanix highlights in their guide?
Yeah, there are a few more things to consider.
Mm-hmm.
We've talked about minimizing unnecessary traffic. But what about those unavoidable chatterboxes, broadcast and multicast messages? Nutanix has some specific recommendations for how to handle this type of traffic efficiently.
Yes, those gossipy neighbors we need to keep in check. We talked about flood optimization techniques earlier, but is there anything else we can do to optimize multicast traffic specifically?
There is. Nutanix recommends implementing a protocol called IGMP snooping on our physical switches. It's like having a designated listener in each switch that pays close attention to which devices are actually interested in receiving multicast messages.
So instead of flooding the entire network with every multicast message, the switch intelligently filters the traffic and only sends it to the devices that need it. That's a clever way to reduce congestion and improve efficiency.
Exactly. It's like having a targeted mailing list, instead of sending junk mail to everyone in the neighborhood. And Nutanix doesn't stop there. They recommend enabling IGMP snooping on the AHV virtual switches as well, which reside within the Nutanix hosts themselves.
So we're implementing this intelligent filtering at both the physical and virtual layers of our network, creating a multi-layered approach to optimizing multicast traffic flow.
Precisely. It's all about ensuring that our network resources are being used efficiently, and that those multicast messages are reaching their intended recipients without creating unnecessary noise.
Okay, so we've got IGMP snooping covered. What other multicast optimization techniques does Nutanix recommend?
Another important one is VLAN pruning. This involves limiting the number of active VLANs on each switch port to only those that are absolutely necessary. It's like decluttering our network and removing those unused VLANs that are just taking up space and potentially causing confusion.
It's like cleaning out our closets and donating those clothes we haven't worn in years. It frees up space and makes it easier to find what we're looking for.
Exactly. And by reducing the number of active VLANs, we're also reducing the amount of unnecessary traffic on the network, further improving efficiency.
I'm definitely sensing a theme here. Nutanix is all about eliminating waste and maximizing efficiency in every aspect of the network design.
Absolutely. They understand that a well-optimized network is crucial for achieving the performance, resilience, and scalability that Nutanix is known for. Now, before we wrap up this deep dive, I want to circle back to a topic that I think deserves a bit more attention: RDMA.
Yes, RDMA. We touched on it briefly earlier, but I know it can be like a real game changer for performance, especially for those data-intensive workloads. Can you remind us how RDMA works its magic?
RDMA, or Remote Direct Memory Access, allows devices to bypass the traditional TCP/IP stack, which can be a bit of a bottleneck for high-speed data transfers. Instead, it enables devices to directly access each other's memory, as if they were part of the same system.
So it's like having a secret back channel for data to travel between devices, bypassing all the usual checkpoints and security screenings.
That's a great analogy. By eliminating that overhead, RDMA can significantly reduce latency and boost throughput, making it ideal for applications that demand lightning-fast data access.
Now, we mentioned earlier that RDMA requires specific hardware support. Can you elaborate on what we need to look for in our switches and NACs?
Absolutely. On the switch side, You'll need to ensure they support features like lossless Ethernet, data center bridging, or DCB, or priority-based flow control, PSC. These features are essential for handling the high-speed, low-latency traffic that RDMA generates.
So we need switches that are specifically designed for RDMA traffic. What about the Nutanix hosts themselves?
Your Nutanix host will need compatible network interface cards, or NICs, that support RDMA. Fortunately, Nutanix provides a compatibility list, outlining the certified NICs so you can easily check if yours make the cut.
And I remember you mentioning that newer versions of AOS have simplified the implementation of RDMA with something called zero-touch RDMA.
That's right, zero-touch RDMA, or ZTR, takes the guesswork out of configuration by allowing the NICs to automatically negotiate RDMA settings without any manual intervention. It's like having a self-tuning engine for your network, optimizing performance behind the scenes.
Wow, that sounds incredibly convenient. It seems like Nutanix is constantly innovating to make complex technologies like RDMA more accessible and easier to manage.
Absolutely. They're always looking for ways to simplify deployments and empower users to get the most out of their Nutanix infrastructure.
Well, I think we've covered just about everything there is to know about building a rock-solid physical network for Nutanix. We've explored the hardware, the design principles, the security best practices, and even some of those advanced optimization techniques.
It's been quite a journey, and I hope our listeners now feel equipped to create a network that can truly unleash the power of their Nutanix environment.
I agree. We've packed a lot into this deep dive, but before we sign off, I want to leave our listeners with one final thought. While we focused entirely on the physical network in this episode, don't forget about the power and flexibility that virtual networking can bring to your Nutanix environment.
That's an excellent point. Nutanix offers a suite of powerful virtual networking tools, like flow virtual networking, microsegmentation, and network visualization, which can further enhance your network's capabilities and security.
Exactly. So while a solid physical foundation is essential, exploring those virtual networking options can unlock a whole new level of control and optimization.
Well said. It's like building a beautiful house. The foundation is crucial, but the interior design and furnishings are what truly make it a home.
That's a perfect analogy. And with that, we'll wrap up this deep dive. We hope you've enjoyed the journey and learned some valuable insights along the way. Until next time. Keep exploring, keep learning, and keep pushing the boundaries of what's possible with Nutanix.
Happy networking.